4 secant x times tangent x plus 2 secant squared x, or sorry, minus 2 secant squared x dx. All right, so we have two different terms inside this integral. We also see we have two different constants, right? This 4 and then we have this 2. Right, so what should we do? What might make it a little easier for us to evaluate this? Yeah, we separate them. So when we separate them, we're going to have 4 secant x tan x dx plus, sorry, I keep saying plus, minus the integral of 2 secant squared x dx. And then like before, we can just pull out those constants, right? So we bring that 4 on the outside, we have that secant x tangent x. No, you don't have to separate them on the test, but you just have to keep in mind if you didn't do that, because you see that there's a 4 and a 2 there, you could just leave those constants inside, or you could factor out a 2 and then have this become a 2 and this become a 1. Does that make sense, Nathan? Awesome. Yeah, so if you leave them in, just keep in mind that you can only bring constants out if it factors out of all the terms if you keep it in one integral. Which is why I think it's a lot of times good to separate them, especially early on, because it's easy to make mistakes like that. Oh, and I forgot the dx. Has he stressed the importance of putting the dx at the end? You really don't want to forget that. So the method you suggest for easily remembering the rules of these. My biggest suggestion is you know your derivative rules. Do you feel good about your derivative rules, Devin? If you know your derivative rules really well, you just need to think about it backwards. Like especially here. Let me derivative rules or antiderivative rules while I talk about it, so I can reference it. So does anyone remember the antiderivative of secant tangent? Yeah, it's just going to be secant, right? And we would have that 1 over a, but there's nothing being multiplied by that x, so we're just going to have a regular secant x. That's going to be 4 secant x. And then what about secant squared x? Yeah, tangent x. And then we have our plus c. So this would be our final answer. All right, and to answer your question, Devin, so when I learned these, I think I didn't have to memorize this a part that was in there, and there's a reason why I didn't, because you learn another method later on how to deal with those without those specific rules with the constants. So honestly, I would just kind of think of it as when would you see the negative 1 over a when x is divided by a number? So we just did a problem right here where we had theta divided by 3. So 1/3 is what our a was in this problem. Our a is equal to 1/3. So we brought our 1/3 down under the a. And then we just use keep change flip to get that to a -3. So it's still a constant, it's just a fraction, it's just not a whole number. Yeah, so if it was 3x, then you would have just -1/3, right? You would divide by 3, exactly, because you would plug a in right here. Yeah, that 1/3 was from this theta over 3 in the initial problem. But to talk about how to remember these, so I would just think of them as similar to your regular derivative rules, and especially if this a stuff messes you up, right? Because if you rewrite this, this is just e to the x plus c, and this is just x up there, and let's just say this is sine x, and that isn't there. It looks a lot like your regular derivative rules, but just backwards. And you can even think to yourself, okay, well, like if you don't remember whether the derivative of sine is negative cosine or positive cosine, you can go back and say, okay, you know, derivative of sine x is going to be cosine x. Derivative of cosine x is going to be negative sine x. And derivative of negative sine x is negative cosine x. And then it goes all the way back up here. So that means negative cosine x comes before, and there'd be a negative. So you can kind of think about it in terms of the derivative to make that connection. I don't know why I highlighted it in green. I'm sorry if anyone's colorblind. But yeah, so like literally just think of it as backwards derivatives. Like you don't have to think of this is my antiderivative rule. Think of it as backwards derivatives. Yeah, my suggestion to you would be to write them all down without the a's and look at it that way, try to remember it that way, and then just if there's an a, just remember that it's going to be, you're going to multiply by 1 over a, right? So you would leave all those negative signs there, right? But all the ones that have those a's, you're multiplying by 1 over a, except for, is there one that you don't do that with? Except for the secant, it looks like. All of that's true except for this one, right? If you notice all the ones without the 1 over a, let me highlight them. So that's the 1 over a, 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 1 over a. All of them have that 1 over a multiplier if there's that constant. So my suggestion would be to you is just to write it normally, and then if you see that constant in there, write to yourself a equals that constant. I'm just going to call the constant c. And then you just divide 1 by that constant, right? And your constant can be like 1/3, and you divide by 1/3, or your constant could be 2, or it could be 100. Do you kind of see the pattern? It doesn't matter what the constant is. If you just rewrite them as that, and then just remember if there's a constant multiplier, then you're going to be dividing by that constant. And I guess you can remember this is the only one that if it has an a where it's not like that, you can just remember that that it's extra. It has a little x on the outside, so secant's extra. I just use like a little mnemonic like that. Yeah, and yeah, no problem. And I guess another thing to note with these two specifically is that the a and these are squared. So you need to make sure that your a value is just a, right? So whatever this constant is, you can just take the root of, right? So if this a in this scenario is 4, right, you could divide by root 4, which would just be 1/2, right? Does that make sense for those two? The ones that have the weird 1 plus x squared, or the roots 1 minus a squared x squared, those are kind of separate, but it's still the same principle. Am I making sense? Those are just the kind of things I would use to remember it if I were you. But I know my brain doesn't necessarily work exactly the same way it does for everyone here. Um, so I do hope those tips helped, um, even if I wasn't explicitly very clear. Um, awesome. Okay. Um, all right.